Okay, so over the next couple of days, you're going to hear about all the exciting things going on in machine learning. You're going to have about new algorithms, new applications, and you're going to leave the conference energized. What I'm going to do today is I'm going to be a bit of a Debbie Downer, and I'm going to spend the next 30 minutes kind of de-energizing you, but you guys will catch up by the rest of the conference. So let me start by telling you a few stories. So just to give you a basis of where I'm starting with these stories. So you can tell from my introduction, I've been in the trenches doing machine learning and AI for long before these terms even existed. In my role at Deloitte, I have the privilege of leading AI projects across a number of industries, but primarily financial services. So basically, I live in the trenches. We're not building new algorithms. We're not doing cool stuff. We're actually doing AI on the ground, and primarily in the banks, in my case, but really across a whole bunch of different industries. So let me tell you that what's going on in the trenches is a little bit different from what you probably are going to come away from this conference thinking about. So let me start with a couple of stories. So, because I find people learn better with stories. So I'm going to tell you 3 stories. They're going to talk about kind of how this illustrates what the issues are, and I'm going to talk about some of the things we've been trying to do to alleviate the concerns that I'm going to talk about. So my first story, again, in my job, I am pretty close to a lot of the heads of analytics at a lot of the top Canadian and global organizations. And I talked to them a lot, and one of the gentlemen, and it was a funny conversation, he said, you know what my metrics are this year? So this is like a global bank. He said, I'm going to get my bonus if I do 40 proofs of concept this year, and they're going to really up the game and do 60 proofs of concept next year. So he thought that was pretty ridiculous, as did I, because they weren't measuring him on whether these projects had an impact. They were just basically measuring him on doing science experiments. Another story is around, again, in financial services, but I think it illustrates kind of one of the big challenges that goes on in the market. I was at a bank, and they were building an attrition model for their wealth advisors, right? So basically what happened was, business person got in a room, machine learning data scientists probably paid way too much money, definitely not long in the business, got in a room, and the business person said, I have an attrition problem. The data scientist's like, I can solve that. So what happened was basically the data scientist left the room thinking, all I have to do is predict attrition. The business person's in the room thinking, wow, this data science stuff's actually going to prevent attrition. So the data scientist goes away for 6 months, the business person goes away for 6 months, they come back, the data scientist presents the attrition model, and it slowly dawns on the business person that there's a number of major problems with this. One, if the baseline attrition rate for, say, a financial advisor in this case is 0.1% per month, and my model predicts, has 100x lift, I'm still going to be 99%, I'm going to be wrong 99% of the time, because 1% I'll only have, at 100x lift, I may predict the probability of attrition of 1%. How many phone calls do you think a financial advisor is willing to make to their customers when they're going to be wrong 99% of the time with this new fancy machine learning? You can probably guess precisely 0. But let's just say hypothetically that person had, that model had calculated a 75% probability of attrition. So more likely right than wrong. Still not useful, because what they never figured out in the room was, what the hell am I going to do with a probability of attrition? What's the advisor supposed to do? Call somebody up and say, hey, I hear you're leaving the bank. I guarantee, and I know this from personal experience, this will cause the attrition to go up. So basically, the model is utterly useless. 6 months, $500,000 sitting on the shelf. And my last story, this is the one I think that the machine learning folks are probably in the other session, so they won't, but anyway, this is going to be the most offensive to this audience. So my last story, so part of our work is we do something called model validation. So in financial services and certain parts of a bank, the models have to be validated by a third party. Not like test and training validation, but like, were they built on sound principles? Were they solving the right problem? Were the techniques appropriate? In some cases, the model explainable? What are the risks of deployment? Yada, yada, yada. That stuff has to be done. So we do a lot of third-party model validation because we have a strong machine learning team. So I sat down. This would be a top machine learning team. I won't say who it was. Sat down with one of their leaders. And what this person said to me was, basically we're going through the, okay, what was the problem you're trying to solve? And he basically answered, well, the business told us what the problem was. I'm like, okay. Not the answer that I was hoping for, but okay. And I said, what are the data sets? How did you identify the data sets you were going to use? Well, the business people told me what the relevant data sets were. I'm like, okay. Not an answer that I wanted to hear. And then I said, well, how'd you do your feature engineering? Now, in Catherine's conversation, there's a lot of buzz. You would have heard it, that you don't have to do feature engineering, et cetera, et cetera. But when you're working with tabular data, I got news for you. People are still better at feature engineering, people in the field, than most machine learning algorithms. So you can certainly get there a lot faster. But anyway, I asked this question. And the answer was, I use deep learning. I don't need to do feature engineering. And in any event, it's out of scope. So I'm like, okay, so the business question's out of scope, the data's out of scope, feature engineering's out of scope, deployment's out of scope. So what is your scope exactly? And the answer I got was telling, because what he basically said was, my job is to take a data set that somebody gives me, take a target variable that someone gives me, and choose an algorithm and wire it up, build a model, and I'm good to go. That kind of stuff happens all the time. So what do we learn from these? Before we get to what we learn, well, actually, I'm going to go ahead of here. So what did I learn from those three stories? One is that executives basically don't know what they're asking for half the time, right? So you have a demand problem. Two is the data scientists who are supposedly leading this work don't really understand that their scope of responsibility is not to build a model, but it is to actually get something in production that the business will find useful. And the third sort of takeaway from these stories is that people are just piling out proofs of concept and they think they're actually doing something, right? And what I like to often say when a business says to me, I want to do a proof of concept, I always say to them, what are we trying to prove here? Because if we're trying to prove that math works, I think we're good, right? I think what we need to prove is that you can get some value out of this, right? We don't need to prove that machine learning works. It's kind of built into the way we build models. Now, don't take my word for it. I was just, LinkedIn has some pretty decent machine learning, and I was just on my LinkedIn feed, and I came across this. Now the post isn't really it's kind of mostly content free, but it's really funny. And it's really funny because it kind of points out what I think is going on in the market. So I don't know this Ben Taylor person, but I just couldn't stop laughing, and I sent this out to all my friends. So if you look at the second paragraph, so he's basically talking about the hype, and in the second paragraph he says, the saddest thing about data scientists team taking 12 plus months to build something is many times it ends up being the wrong thing. But I can guarantee you this happens way more than people think, and guess who's responsible for that? We are as a community, right? So maybe a funny post, but it's a scary concept. And if we don't solve for this kind of thing, I'm not saying machine learning isn't valuable. It's super valuable. I'm all on board. I think we can really make a difference. But there's going to be a lot of blowback because we're not we're taking a very narrow view of what our role is. So let's just summarize, in a very, if I had a money slide, this would be the money slide. What are the things that we see in my company, and I've spoken to other leaders and other analytics companies, what do we see that's really going on? So I say thematically, there's 5 big themes. First of all, the organizations really aren't getting the businesses to align with the data scientists, right? That's probably not a surprise to you. siloed data sources, we've heard this over and over again. 80% of the work is on the data, et cetera, et cetera. That's true when you're doing the feature engineering. But the number of projects that I've done with large organizations where they basically, no one, like the data's all over the place. I have to go to every line of business and say, what the hell's this, right? That is a painful process, right? It's not a technical problem. It's an organizational problem. Infrastructure constraints, I won't kill myself on this. You would all know about that, other than, you know, like I don't know a single bank that's actually done one data lake implementation and it's worked, right? Some of them are on like version 3 and people still don't use them. Shiny objects, so we're really responsible for that, right? Do cool stuff, probably not allowed to swear here. Do cool stuff and I'm good, right? Well, guess what? Sometimes logistic regression is good enough. In fact, a lot of the times it's good enough with structural data. Not that I think it's exciting, but it gets the job done. And then I sort of harped on this earlier. We're just messing around doing proofs of concept without actually sort of thinking about what this is going to be used for and worrying about the last mile, right? So how the hell is this thing going to get into production and how is it going to get used? Okay, so are you all sufficiently depressed? There's a few things, so I can't solve all of this. What I will share with you now is just some of the tactics we've used to get past these things. But if you'll look here, what you'll notice is like 4 or 5 of those things are organizational. They're not technical. No one's saying machine learning doesn't work. What we're saying is a lot of these things don't work because we don't do a lot of the other things right. Right, so I'm going to go through these fairly quickly. And there's some, I can't stand icons, but I'm told I should use them. So these icons actually have a meaning. You can probably figure them out better than I can. But basically, these are 5 tactics that we used. And it's kind of the challenge areas that they addressed on my previous slide. So training executives, and introducing data governance, yawn, but really important, like using cloud, using multidisciplinary teams, and changing your delivery approach. So on executive education, so a lot of these executive education programs are geared to try to teach some VP somewhere how to build a model. That is a waste of time. First of all, you make them feel like a dummy. Secondly, they're never going to do it, right? So what are we supposed to educate them on? They need to understand 2 things. One, how to recognize a machine learning problem when they see it, right? So they're going to have to help identify the areas of the business where this might apply. And 2, they need to understand they just can't throw it over the fence and hope the smartest person in the room is going to sort it out, right? Because the problem with data scientists, it's actually not our problem. It's often we have our problems, but this one is on the business side. They're always saying, I got this dude's got a PhD, smartest guy in the room, he'll figure it out. Guess what? We're really good at data science. It doesn't make us good at everything else. Just because I have a PhD in particle physics doesn't mean that I can do everything there is to, right? There's a lot of stuff I can't do that aren't in my skill set. So the program that we have one at Deloitte, we've trained, there's like 4 or 5 organizations we've trained literally 100 plus VPs at each one. Like senior execs, this is what it can do, and you don't get to throw it over the fence. You got to be in the room, you got to be with us all the way to the end. I'm not going to kill myself on data governance. Forget this is just like I wouldn't call it eye candy, but it's just a bunch of pictures. What I want you to take away from this is organizing your data is not, again, is more of a process and people thing. It's not like, hey, build a data lake. You need to have processes where, especially in mature industries like the ones that I deal with, every line of business has this really super critical data that only people in the line of business understand, right? So if I'm in a bank and I'm in credit cards, the credit card data is awesome. If I want to use it to do mortgages, nobody in the mortgages area knows anything about that data, right? So you need to put together processes around sharing the information about what is in this data and making sure it's available to everybody. And that's what good data governance is about. So this one I feel passionately about, right? So, and I kind of touched on it earlier, we use multidisciplinary teams. So the AI practice at Deloitte has 500 people in it, right? So everyone's like, holy crap, that's a lot of data scientists. It's not a lot of data scientists. We probably have 20 like hardcore, like kind of write papers and have PhDs in machine learning. Probably have another 20 people who can do relatively straightforward machine learning problems. Then what are the other 450 people? Who are they, right? So I'll show you later our project delivery approach, but you'll notice the data scientist is only a small piece. Now you won't be surprised that there's data engineering, there's visualization. This is all kind of color-coded, so red's technical, so you get to purple in the end. It's very exciting. But we also have we have project managers, not PMPs, but like people who actually drive the project, right? So these are functional areas, not technical. We have business analysts, and then we have this really weird one, which is an information designer. So an information designer is not somebody who builds Tableau dashboards. An information designer is somebody who comes out of OCAD, typically, that's where we typically get them, and they do design thinking. So they sit down and with the client in our sessions, and I'll talk about our delivery model in a second, and they try to get the client to see the world in a different way so that we can actually solve a problem that's relevant to the client. So we're trying to bring the client along in a journey. So these people are completely non-technical. They dress funky, they have weird degrees, but they're super useful in the sessions that we do with clients. We don't use them throughout the project, but to set the project up and get client thinking a different way, it's a super important skill set. The bottom line is, for every data scientist, we have like 5 other skill sets, and these people are all shoved together on a project and said, you win or lose together, including the client. I am not going to kill you with this. This is actually our delivery model. Is there like a little fancy point? Oh, awesome. It's green too. Okay, so what most people in the audience would typically recognize as their jobs is this, maybe a little bit of data work. Yeah, probably this, right? What's all this other stuff, right, that's going on here? So I won't spend too much time here, but if we have a decent use case identified, we spend a lot of time with the clients, including the business people, locking them in the room and going over, okay, if the model does this, what are you going to do with it? What are you going to do with it? How is this useful? And you end up with a much smaller set of deliverables to the client than a big one, so you don't overload the information. So this is all focused on what's the person going to get, how are they going to do things differently, and the other thing we spend a lot of time on here is figuring out how the hell am I going to put this into production? Like, what are the barriers? So we basically assume the model's going to work, because they usually do, and then we figure out all of the other things we need to figure out without building the model, right? So again, our job is not this. Our job is all of this, right? So I'm pretty much done here. So just in summary, and I don't have any time for questions, unfortunately, maybe 30 seconds. Like the bigger organizations, not the AI first ones, are struggling. We know the technical challenges. The organizational challenges are probably worse and not well acknowledged. And really, we haven't solved everything. I just showed you some tactics that we used. Thank you.
Doesn't this all scream business system analyst in AI? If somebody who knows technical and know business, he can answer and fill the gap between the hard coding PhDs, developers, and the business? Because I don't think educating executives I don't think they will be very promising usually, because they have their business working on it. Will this fill the gap, you think?
So the question was like, can you get this kind of translator thing? And there was a lot of talk about that a while ago. And and if you can, my answer to that, and I'm sorry, with all due respect, is you're asking for a unicorn, right? Do you believe in unicorns, right? So usually, yeah, you do. Okay, they're cool. You got your answer. The reality is, that's a rare skill set. Usually very good at one thing and kind of good on a secondary skill set. So yeah, we do have data science people who can kind of go over there, but ultimately, like trying to get the one individual to go across both isn't as effective as actually putting together a team that covers all of it, including like your end stakeholders, the technical people on the team. We literally lock people in a room, sometimes for 4 weeks. Like the data scientists can't stand it, the business people can't stand it. but we're trying to get alignment on what the hell it is we're trying to solve for, and to get an understanding of where the other person's coming from. Like, what are the constraints? So that would be nice, but you can't build a business on unicorns.
Thank you, Ian, for the nice talk. This is not a question, but this is just to say that I work at TradeRev and I lead the machine learning team there. So I can resonate with a lot of challenges which you have posted, and I'm very happy to share that we are doing a lot of things, what you have mentioned, like multidisciplinary teams, and we have pipelines and production and everything. So I just wanted to thank you on sharing your challenges, and tell that we are also having the same challenges, but we are also moving forward with them, and we are doing a lot of things which you have also showed. Thank you.
And that's good to hear, and I'll get off the stage now, but I just, like, it's good to hear that people are doing that. I just feel like as a community, like, we need to solve for this, or like, people are gonna start saying, like, where's the value, right? So happy that you guys are solving for it. Like machine learning is cool, like, let's do all the things around it well, so that our clients actually think we're worthwhile before the winter ends up being, the AI winter ends up being a bit longer than it needs to be. Thank you.